I hope all are doing well and good. Welcome back to Ravi Math Space YouTube channel for math education. Myself, B. Ravi. Today we are going to learn and discuss the exercise 1.3 from real number chapter. In that, first question is prove that root 5 an irrational number. How to prove? Already I have explained the how to prove the irrationality in the previous videos. So if you want to watch that video and learn the concept. After watching that video, you can continue this video, you can understand the better and better. Okay. So by using contradiction method, we are going to prove the irrationality. What is the meaning of contradiction? Whatever given in the question, that statement we are going to take the opposite statement. So in the statement given it is irrational number, we are going to take the opposite statement is nothing but as a rational number statement. So by using that we are going to prove. Okay? Okay. Proof. Now let us assume root 5 is a rational number. Root 5 is a rational number. When it is root 5 is a rational number means this number should be in the form of p by q and q naught is equal to 0 and p and q are integers and satisfy the condition is co-prime. What is the meaning of co-prime here? So p and q have no common factor other than 1. That is the co-prime condition. This co-prime condition satisfies means it is for rational numbers. Now let us check it satisfies or not. So root 5 I can write as in the form of p by q. So where p and q are integers, rational number conditions. Next one is q naught is equal to 0 and p and q are co-primes. Co-primes. It is the rational number conditions. Okay. Now what we should do? First we are going to remove the what it is root. Root value we are going to remove. How? By squaring on both sides. Squaring on both sides. What we are going to get? Root 5 whole square p by q whole square. Simplify it. What we are going to get here? So square and root get cancelled. Now remaining is 5. Now p square by q square. Yes. Now how I can write here? This I can write as a q square is equal to p square by 5. What is the meaning of this? Can you tell me anyone? Meaning is p square divided by 5 or 5 divides p square. Therefore 5 divides p square. 5 divides p square. Meaning is what here? According to theorem 1, how I can write 5 divides p square? 5 is a prime number. P is a positive integer. Now p divides a square, then p divides a also. Meaning is 5 divides p also by theorem 1. Yes or no? By theorem 1. By theorem 1. Therefore, what is the meaning of that 5 divides p means 5 is a factor of p. 5 is a factor of p. It is for 1, it is for 2. 5 is a factor of p. Now What about Q here? 5 consists, P consists factor 5. Then what about Q here? Q consists anything? Okay. So what we are going to do here, this instead of P, I am taking some value. What value? I am considering let P is equal to how much? 5m. 5m for some integer m. Some integer m. Sir, why we are taking only 5m, not 2m, not 10m? Reason here, already here P consists of 5 there, na? Whatever factor here there, that factor only I am taking. Now m is any integer will become. So therefore P is equal to 5m. Suppose here 3 there, we can take 3m. Here 2 there, I can take 2m. Here 7 is there, I can take 7m. That is the logic here. Don't get confused here. Next, now substitute this value in this equation. So P value substitute in 1. What we are going to get now? Yes. Therefore, Q square is equal to, in terms of P, I can replace 5m means 5m whole square by 5. So simplify means 25 m square by 5. So cancelize, we are going to get 5m square. So therefore Q square is equal to 5m square. I can write Q square by 5 is equal to m square. Again see here, Q square divided by 5. Otherwise 5 divides Q square. Again by using theorem 1 I can write as a 5 divides Q square, then 5 divides Q. 5 divides Q by theorem 1. By theorem 1. Understand? So meaning is what here? 5 divides Q means, I will write here, not visible. 5 divides Q by theorem 1. So 5 divides Q means 5 is a factor of Q. Yes or no? Therefore 5 is a factor of Q. It is equation 3. From 2 and 3. From 2 and 3. What we can say? Therefore P and Q have common factor 5. Common factor 5. So this is contradict to fact that P and Q are co-prime numbers. Yes or no? So this is contradiction to co-prime number. Rational number means what here? P and Q are should be as a common factor only one only. There is no other factors. But here what we got here? P and Q have common factor 5. So this is contradict the fact that P and Q are co-primes. Therefore, our assumption is wrong. What we are assuming here, root 5 is a irrational number, is a wrong. Hence, root 5 is a irrational number. Root 5 is a irrational number. This is the proof. Like this we are going to prove any irrational number. Any irrational number. Very simple concept here. So once again see first onwards. First root 5 we can take Contradiction method means exactly opposite statement of the given statement, which is nothing but as a given statement is irrational, we are going to take the rational. Therefore, let us assume root 5 is a rational number. So it is rational number means it should be in the form of p by q, and conditions are we are going to satisfy. So p and q are integers, q not is equal to 0, and p and q are co-prime numbers. That condition we should satisfy. Now satisfying or not, once check out. First, squaring on both sides, we are going to remove the square root. Then we are going to get the phi is equal to p square by q square. Now transport here, we are going to get the q square is equal to p square by phi. It is in the form of phi divides p square. Theorem 1. P divides a square, then p divides a. So by using that condition, I can write as a phi divides p. Meaning is what here? Phi is a factor of p. So p consists one factor, that is phi. Similarly, what about q? What about q? Instead of p, I can replace what? Some value, that is p is equal to phi m. Let p is equal to phi m for some integer m. Now substitute the p value in equation 1. We are going to get the here m square is equal to q square by phi after all simplifications. Again here we can apply the theorem 1. Phi divides q square means phi divides q also. Meaning is phi is a factor of q. So from 2 and 3 we can say that p and q have common factor phi. This is the contradiction of the fact that co-prime numbers. Therefore, our assumption is wrong. What is our assumption? Root 5 is a rational number is wrong assumption. We can conclude that root 5 is a irrational number. This is the proof of the irrational numbers. Like this, any irrational number we can prove. I hope all children understand the concept thoroughly and perfectly. Second question is, prove that 3 plus 2 root 5 is an irrational number. Irrational numbers. Okay. So, how to prove? What is the procedure? Already I explained in the previous video. You can watch. You can understand better. Okay. Now, first step is what here? Let us assume this number is a rational number. That is the first step. What is now? Let us assume that 3 plus 2 root 5 is a rational number. When it is a rational number, then it should be in the form of p by q. That condition we should write here. Yes, it is in the form of p by q. So where conditions we should write? What condition? Rational number condition. P and q are co-primes and denominator q not is equal to 0. This is the first step. Next step is what? Second step. Now this number should be equal to p by q form. Therefore 3 plus 2 root 5. Now 3 plus 2 root 5 equal to p by q. So now what we should do? This root 5 you are going to keep here only. Remaining whatever numbers are there, you are going to transport that side. So how we can transfer? First this plus symbol there, now you have to transport that side. So plus become as a minus. Therefore what I can write here? P by q minus 2. And again this 2 also same that side. So 2 operation is multiplication if I transport that side. So what we are going to get, LHS to RHS means it's going to be as a division. So P by Q minus 2 by 2 by 2. Understand here? Since what I can write here, already we know P by Q is a rational number. This also 2 is a rational number. The subtraction, difference also rational number, and division also rational number. Understanding here? Concept is what here? Here you should understand very careful here. Already we know what we know. Rational number addition, rational number subtraction, rational number division, rational number multiplication. If I do operations means the answer always we should get only rational number. That is the concept here. So here rational number subtraction. So we will get answer rational number only. Again if I divide with the rational number means again it become as a rational. So what I can conclude here, this total number is a rational number. That is the concept here. Okay, I am writing here. So P by Q is a rational number. P by Q is a rational number. When P by Q is a rational number means addition and division also rational number only. So here difference and here difference, one more operation is what it is, division. So rational number difference as well as division. The answer should be what become again rational number only. Yes or no? Already this fact is we know. Why? Because in the previous classes we proved rational number operations, addition, subtraction, multiplication, divisions. The answer should be rational number only. Already we know that fact. So because of that reason, so I can write as a P by Q minus 2 by 2 will be rational. 2 will be rational. So suppose this total part rational means automatically it is equal to rational number only. Therefore root 5 is a rational number. But we know what we know. Root 5 is a irrational. What we know? Fact here, root 5 is an irrational. So here contradiction, yes or no? So that's why here I am writing. So this is contradicts the fact that, what is the fact here? Root 5 is an irrational. Root 5 is an irrational. So here this fact is there. Now this fact is what it is become? Contradiction. Contradiction means wrong. Therefore our assumption what is our assumption here? 3 plus 2 root 5. Our assumption is wrong. What we assume here? 3 plus 2 root 5 is a rational number. Our assumption is wrong. Understand it here? Hence Hence 3 plus 2 root 5 is an irrational. Hence prove. Very simple. First we have to assume the given number as a rational. When it is rational, it should be in the form of p by q. So here one side become as a total rational number. Automatically root 5 also rational number. But we know that root 5 is an irrational. So this is the contradiction fact that root 5 is irrational. Therefore our assumption is wrong. Hence 3 plus root 2 root 5 is an irrational. Simply proof. Understanding here. The procedure is same only. Every problem procedure is same, like only we have to prove. Okay. If you want to miss, take fatafat screenshot. Okay. The next question is in that exercise. Third question is, what is third question here? Next, third problem is prove that following are irrational. First one is 1 by root 2. Second one is 7 root 5. So we have to apply same previous problem procedure and we are going to prove here. Okay. First 1 by root 2 is irrational. We are going to prove here. So first what we are going to assume here? Yes, it is the first problem. Let us assume that what is 1 by root 2 is a rational. Yes or no? When it is rational means it should be in the form of, it is of the form, what form? P by Q, where condition is what here? P and Q are co-primes and Q naught is equal to 0. Now this number 1 by root 2 equal to P by Q. Already it is rational number form. So it is in the form of P by Q. Already we know that. What we know? So denominator should not be irrational number. So what we should do? We have to rationalize. By taking the denominator conjugate. Meaning is 1 by root 2 into root 2. So numerator, denominator multiply, the denominator conjugate means same whatever is denominator is there. Exactly we have to take that only opposite. So root 2 into root 2. This is the conjugate of that one. So P by Q. So what we are going to get now? Root 2 by Q is equal to P by Q. So it is root A into root A. So that is nothing but root A square, which is nothing but A is answer. Already we know this is. Now what we should do? Just to transport this side. Therefore root 2 is equal to 2p by q. So already we know 2p also integer, q also integer. Both are integers. Then it is a rational numbers. Here I will write now. Since 2p and q are integers. So 2p by q is a rational number. number. Rational number. When it is rational number, when it is a rational number, automatically right side part is total become now rational number. So this right side part equal to the left side, meaning is automatically, therefore root 2 is a rational. Root 2 is a rational. Root 2 is a rational. But we know. What we know here, root 2 is an irrational. Yes or no? Root 2 is an irrational. This is fact we know. So this contradicts the facts. What fact? That fact. What is the fact here? Root 2 is a irrational. 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 So our assumption, what I can write now? Therefore our assumption is wrong. Yes or no? Our assumption is wrong. So what I can write now? Hence 1 by root 2 is an irrational. Hence prove. Very simple. First, let given number as a rational number. When it is rational number means it should be in the form of p by q. So when it is p by q means both are equal, LHS to RHS. Now sign this one. Here rationalize. Why? Because here denominator is irrational number is there. So rationalize by taking the denominator conjugate. So numerator denominator same number apply. We will get root 2 by 2. Now send this to this side. It become as a root 2 is equal to p by q. Already we know this is integer. It is integer. Then we can say 2p by q is a rational number. When it is rational number, automatically root 2 is a rational number only. But we know, what is we know? Root 2 is an irrational. Root 2 is an irrational. So this is contradict the fact that root 2 is irrational. Therefore our assumption is wrong. So what is our assumption? 1 by root 2 is irrational is wrong. Hence 1 by root 2 is an irrational. 1 by root is an irrational. So this is the simply proof. Understand here. Now next question. What is the next question? 7 root 5. 7 root 5. Same procedure apply. Whatever procedure. What we again first procedure. Let us assume that what is 7 root 5 is a what it is? Is a rational number. Is a rational number. Yes or no? When it is rational number means it should be in the form of what form? It should be in the form of what form? It is of the form, what form children? Form p by q, meaning is rational number condition. So what are the now here again write p and q are co-primes and q naught is equal to 0. This is the rational number conditions. Now what we should? 7 root 5 equal to p by q. What we should do? This rational number here, it is the combination of rational and irrational. This rational number sent to this side. Then we can get root 5 is equal to P by 7Q. P by 7Q. So how to get means very simple. So operation in between multiplication is there. If I transport means the multiplication operations become as a division operations. That's why here multiplication is there. It become means division. So it become as a division. Therefore we can get here answer is root 5 is equal to P by 7Q. Now by observing this, P is a integer, 7Q also integer. Both are integers means P by 7Q is what here? It is a rational numbers. Already we know this one concept. Since P and 7Q are integers. So P by 7Q will be a rational number. So this part is rational means automatically root 5 also rational. Therefore root 5 is a rational number. Root 5 is a rational number. But we know what we know here. What we know, root 5 is an irrational number. Root 5 is an irrational number. So here contradiction. So this is contradicts. This is contradicts the facts. What is the fact here? Contradict the facts that root 5 is an irrational. Therefore, what is our assumption? What is our assumption here? 7 root 5 is rational number is wrong. Our assumption is wrong. Meaning is 7 root 5 is a rational number is wrong. Hence we can conclude. Hence we can conclude or we can write 7 root 5 is an irrational number. Hence proof. So this is the simple proof here. Once again see both problems you can compare also. Same procedure I applied here. Don't multiply problems. Just you how to understand the concept means mathematics is very easy. So first what we are going to assume here, 7 root 5 is rational number. When it is rational number means it should be in the form of P by Q. Conditions are P, Q are co-primes and Q naught is equal to 0. Now 7 root 5 equal to P by Q. Now send 7 that side, it become as a P by 7Q. Now we know P and 7Q are integers. Then it is a rational numbers. When it is rational number automatically, so right side number is rational number means automatically left side number also rational. Therefore I can write root 5 is a rational number. But we know fact. What fact? Root 5 is an irrational number. This is the contradiction. The fact that root 5 is an irrational. Therefore our assumption is wrong. What is wrong? 7 root 5 is rational number is wrong. Hence we can conclude that 7 root 5 is an irrational number. Like this we are going to prove the irrationality of a numbers. I hope all are understanding the concept thoroughly and perfectly. Yes. If you want to means take screenshot fatafat. If you understand the concept, please do subscribe and share to your friends my channel. Thank you. Until take care. Bye bye.